So questions about so questions about, now there are exceptions to the cell wall, right? So this is, let's quickly go through the exceptions. Exceptions. Mycoplasma, there's only 3 organisms we discussed. Thermoplasma and mycobacteria. Now out of these 3, how many are bacteria? Which ones are bacteria? 1, 2, or all? The ones that are bacteria are, this is a bacterium, this is a bacterium, this one is an archaea. Okay. Which one of these don't have a cell wall, period? No cell wall of any shape. The 2. Remember, the plasma, if it ends with plasma and it's a bacterium, it doesn't have a cell wall. I take that back. If it ends with plasma and it's a prokaryote, it doesn't have a cell wall. But you have to remember, thermo is an archaea. Okay? And one way to remember, we talked about archaea being extreme environmental organisms. Thermo refers to heat. Now, how are they different? Mycoplasma compensates by having well, no, not this is the mycolic acid here. Mycoplasma compensates by having sterols, right? Because remember, it's one of the few organisms that is a prokaryote and has sterols. Thermoplasma compensates by having an extra rigid cell membrane. We'll talk about it in a second. Mycobacterium has a cell wall. It's unusual because of what it has. So for example, it has mycolic acid in it. That's unusual. It has lipo-arabinomannan. It has arabinogalactan. It's in the notes. Galactan. But that's what makes it unusual. So please note, it has a cell wall, unusual. That's an exception in that sense. These 2 don't have it, period. Right? So questions about any of this? So the cell wall, again, the single most, because when we discuss antibiotics shortly, we'll come back to it. So please know it well. Okay, so then the cell membrane. The cell membrane is same thing. Try to differentiate between bacterial and archaeal membranes. Very similar to what I started. So cell membrane. Do the same thing. We discussed bacteria. We discussed archaea. With bacteria, really, there are several things to remember. First of all, it's a phospholipid bilayer, right? It has proteins that are integral or extrinsic. And the sterols, sorry, not the sterols. The glycerol is attached to the fatty acids by what type of bonds? Ester, right? Ester bonds. And it has very little sterol. So sterol is very little, arrows down. Instead of sterols, they have what? What are the cousins of sterols? Steroids. The hopenoids. We discussed them. So they have a lot of hopenoids, very little sterols. Okay? Ester bonds. The equivalent in archaea is, first of all, they don't have true lipids, or at least not classic lipids. They have polymers of isoprene. So they have isoprene units. First of all, and also the fatty acids here are branched or unbranched, or not branched. Here they are what? They are not branched. The fatty acids. Here they're branched. So when you're studying, try to compare and contrast these. Here it's ester, here it is what? Ether. And because it's ether, you can have, not because of it, but anyway, you have 2 types of ethers. You have tetra and diethers, right? So you have tetraether and you have diether. Right? So you might have a diagram where I might describe it. If it's a lipid that looks like this, or at least a lipid layer that looks like this, This is tetra or diether?
Tetra.
This is tetra, right? Because you have tetra bonds. You have 4 bonds. 1, 2, 3, 4. A diether would have 2 bonds. So now that the problem of hydrophobicity is still there. If it's a diether, it needs another layer to get out of water. If it's a tetraether, it's 1 layer. So this is 1 layer, this is 2 layers. So going back to thermoplasma, which one would be more rigid, tetra or diether?
Tetra.
Tetra, right? If it's 1 layer, 2 layers would easily slide on top of each other and can separate. So the ones that live in extreme conditions like thermoplasma do not have a cell wall, but they have a rigid cell membrane like tetraethers, actually in the form of tetraethers that allows them to. So questions about this. So that's again the summary of the cell membrane. It's probably just easier to stay on one side. Okay, so after the cell membrane, I think there was nucleic acids, DNA, RNA, chromosome. This will be the focus of chapter 7, so there's nothing really there, plasmids. Same thing with ribosomes. We've discussed these in the molecular biology portion, so you can leave them till then. There's a lot of redundancy. Then I think we discussed pili, right? So on the notes, let me see if I missed anything. Chapter 3. Sorry? I think then we go to, so pili. Oh, there's the inclusion buddies. So here with inclusion buddies, you don't have to go into much detail, but know word association. So for example, what are carboxysomes involved in? Right, photosynthesis. What are storage? What can bacteria store? They can store sulfur. They can store starch. They can store glycogen. They can store PHP, polyhydroxybutyric acid. So it's all there. You don't have to go into much more detail than, again, the first. And also, which ones are you? What are magnetosomes involved in? Magnetosomes, magnetic structures, movement in magnetic fields, right? Makes sense. What magnets can attract or repel, so that's movement. Pili, same thing. Let's do pili real quick. Pili deserve their own different color. Pili 2 types, right? What are they? Common and sex. What are common also called? Fimbriae. What are sex also called? Fertility. First of all, if you had one word to attach their function, attachment, right? That's one function for both. Attachment. What's the difference? Common pili allow them to attach to other organisms, other surfaces. Fertility allows them to attach to each other. Okay? And is this a gram-positive or a gram-negative phenomenon for the most part? Pili are gram. We discussed, remember, what was the organism we discussed them in chapter 9? Which organism has the F plus and the F minus and all that? That was E. coli. E. coli is a gram-negative. Pili are predominantly gram-negative entities. Okay? So, what's the difference? Common pili are many, few, short, long. That's it. I mean, if you know this, that's probably 1 point right there. Questions about pili? Okay, flagella, same thing. Flagella, a little bit more detail about flagella. So for a flagellum has 3 parts. If I can just put it, yeah. You have the basal body. You have the hook. You have the filament. First of all, you can actually go back. Depending on where they are, you can have different names, right? So for example, what is this? This is a single flagellum that's polar, right? If it's coming off from the middle, so we see